So on the notes again, we're gonna go back to the first page. And we're gonna look at the two special cases and then do an example of each one in this video. So special cases are if both variables add to 0, they're cancel eliminated, then you'll have one of two situations. You'll either get 0 equals 0 or a new equation that is always true, like 2 equals 2, 5 equals 5. And if that's true, then we have infinite solutions. Okay, so there's an infinite number of points that work. If instead you get 0 equals a number other than 0, or a new equation that's not true, that's when we have no solution. There's no point that will work. So this is again when the two lines are parallel, and infinite solutions is on a graph when we have the same line when we graph it. And so every point on these lines work. So we're going to look at number 3. I'm sorry, we are going to look at number 4. Okay. Okay. So for number 4, again, the first step is line up your X and our Y's. So we're good. They're lined up. And the second step is either X or Y, one of the variables has to be the same number, but opposite signs. And if I look, neither of them. I have a 2 and a 6. I have a 5 and a negative 15. So it doesn't matter which one I change. I want to multiply one or both these equations by a number to get the X's or the Y's to be the same number opposite sign. So again, this one, it really doesn't matter. Either one will work, but I'm just going to focus on the X because this one's negative and that one's positive. And so I'm going to say, okay, how do I get both of them to be the same number? Well, I know that I could get negative 2 to be a 6 by multiplying by 3. That's what you're going to think about. What could I multiply by to get them to be the same number? And so that's what I'm going to do. I'm going to multiply this equation by 3 to get it to be a 6. So I have negative 6x, and we multiply every single number, like we're distributing 3 to every single number, plus 15y equals 60. And then the second equation, I do not have to change because it's already 6. And so we have now same number, opposite sign, right? And so what we're going to add the equations. So this cancels adds to 0. But if we look, the y's are the same thing, same number, opposite sign. So if they add 15y minus 15y, that's also 0. So we're going to just put 0. If everything cancels, it's equal to 0. Equals, and then we're going to do 60 plus 45, okay, which is 135. So if the x's and y's both cancel, and you get this, you check if it's true or false. So this is false. 0 definitely doesn't equal 135. And if it's a false statement, that means you have no solution. Okay, and so that is my answer. It's no solution. Okay, so let's look at number 6. Okay, so number 6, we also want to solve the system of equations by elimination. And if I look at this, we have an issue. So the first step is always that the variables are lined up and the equal sign has to be lined up, okay? And so because the 20y is on the other side, it's not in standard form. And I need to first change this to standard form. So to do that, I need to move the 20y to the other side. I do that by subtracting 20y from both sides. And that would give me negative 5x minus 20y, I can't combine them, equals negative 15. Okay. And then I have my other equation. And whether you write it on top or bottom, it doesn't matter, but we're just going to make sure our x's and our y's are lined up. Okay. So if it's not in standard form, which again is ax plus by equals c, we need to move around the equations by adding and subtracting the terms by adding and subtracting to get it in standard form. Okay, step 2, again, is we need to make sure that the numbers are the same but opposite signs, either for X and Y. And we notice they're not, -5 and 2, -20 and 8. And I also need to know, okay, I can't multiply 2 by any whole number. We want to do like whole numbers or integers, not decimals, to get it to be 5. And 8, I can't multiply 8 by anything to get it to be -20. If that's the case, I have to multiply both equations by numbers to get them to be the same number. So if I take 5 and 2, what I can always do is I can multiply each equation by the other one. So I'm going to multiply this first equation by 2 and the second equation by 5. Okay? And I'm going to do both positive because one is negative and one is always positive. So I don't want to change the signs. And what that will result in is both of them being 10. Okay, so if I multiply them by each other, I will always get them to be the same number, kind of like we did when we got a common denominator. So this is -10x minus 40y equals -30. And this is positive 10x plus 40y equals 30. Okay, and that's what should happen is now, if I did that step right, is that the x's are the same numbers but opposite signs. And that allows me to add the two equations. -10x plus 10x adds to 0, so it cancels. But then -40y plus 40y also adds to 0. So I'm going to put 0. And -30 plus 30 is also 0. So I'm going to put 0 equals 0. If that happens, this is a true statement. And then we say infinite solutions. So if you get all of them to cancel everything, then it's going to be infinite solutions. Okay, so that is an example of no solution and infinite solution.